this video we want to talk about the for loop. Now the for loop is a counter-driven loop. You can see in the parentheses next to the for keyword, you have three expressions. Now in that first expression, which I just called the initialize counter here, is where you typically declare and initialize a counter variable. This is typically int I, okay, and then you set it either to 0 or 1, and so on, depending on whether you want to count up or down. Then you also have a Boolean expression similar to the while loop. So while this is true, the loop will execute. And then you have another statement right at the end where we change the counter variable. Typically you'll increment it, so I plus plus, I minus minus, and so forth. So I have a few notes at the end here. So what does the execution of the for loop look like? Well, firstly we execute the initialize counter statement, and you'll only do this once. A note here is that the counter variable can also be declared before the loop, and this will make it accessible outside or following the loop. Then we have these two things that will repeat depending on that Boolean expression. So firstly we test the Boolean expression. If that Boolean expression evaluates, okay, and returns true, then we execute the body of the loop. If it returns false, or in other words if it evaluates to false, then terminate the loop. In other words, we exit the loop and we execute the statements that follow the loop. Then what we do is we execute the change counter statement, and then we go back to step 1. So let's say we increment or decrement that counter variable, so either I plus plus or I minus minus, for example, and then we'll go back to step 1. So we'll go and test that Boolean expression again, and maybe in this case it evaluates to false, and then we'll exit out of the loop or terminate the loop. Between parentheses in the for loop you can see we initialize some counter variable. You can also declare it in that same statement. That's also typically done with for loops. We also test it with that Boolean expression, and then we change it, right, in that final expression. You can see that these are statements. They end with a semicolon. Okay, comma separate out expressions. Kind of think of it in that way. Maybe that will help you remember whether these are semicolons or commas. So remember with the for loop that we separate these things out with the semicolon. The for loop implements the ITC principle, so we initialize, test, and change the counter variable, okay, as I explained. Now when do we use the while loop and when do we use the for loop? Well, if we can determine in advance how many times a loop must execute, so in other words when we'll use a counter variable, then we typically use the for loop. Otherwise we'll use the while loop. So as I mentioned, when you do input validation, you'll typically use the do while loop. And as we'll see in a future lesson, when you work with arrays or data structures, which is typically containers, you can think of it as a bag or a variable that contains multiple variables of the same type. Okay, don't worry about it too much, we'll explain it in more detail in that lesson, but typically we iterate through the contents of those data structures by using the for loop for the most part. So the for loop is quite important, so I encourage you to play around with it and understand it before we get to the data structure lessons. A note here is that the for loop's expressions are optional, but it's best practice to always include them. So for example, you can see that I don't have any expression in here. I just have the empty parentheses with those two semicolons inside. Now what you could do is you could add the Boolean expression, okay, that one that goes in the middle. So let's say I less than 10, you can add that second expression in. Then right before the closing curly bracket, you can increment or decrement that, or in other words, change the loop control variable, in this case a counter variable. So right before the loop, let's say int I, and maybe you can initialize it in that first expression, or you can also initialize it before the for loop, and then maybe you can change it again in that first expression in the for loop if you want to do that. Okay, so I have a bunch of options, but it is best practice to add all of your expressions in the for loop, so between the parentheses. Let's look at a few examples of for loops. Now if you don't remember what the for loop looks like or how to write it out, you can type for and then press tab. And so here we do the declaration and the initialization of the counter variable. So I'll just do int I and I'll leave that at 0. Now I can actually press tab, and that will actually jump the cursor and have the variable name selected. Now in this case I'll leave this to I, so I can press tab again, Let's jump to the condition or the Boolean expression, and in this case we can change the length. So I'm not going to use a variable here, I'll just change that to 10. So build and run this, and you can see the value of I is 0, 1, 2, 3, 4, 5 until we get to 9. So it's not going to print 10. Now let's say I want to print this out after the loop as well. Okay, something like this. If I turn build and run this now, I'll get errors. So what I can do instead, I can remove that. So up here I declare that integer, so int I. I'm initializing it as well, you don't have to, but I typically do that. Now you can actually leave that out. Because I have initialized it here, I don't have to initialize it again. So what's important to remember as well with the for loop is that each one of these expressions, so this first expression, this expression right here within this statement, all of these are optional, so you can leave those out. So in this case, I'll do it like this. And what's going to happen now, because this int I is declared before and outside of this loop, I can access it down here. You can see those squiggly lines will disappear as well. Control F5 to run. And you can see this works. I get an extra print now that says int I is 10. So I'll just change the string so we can easily see the string is following the loop. What you can also do is, I'll cut this out, paste it down here, so I'll increment it each time at the end of the loop. Just remember the semicolon. I'll leave the Boolean condition, otherwise you might get an infinite loop. So I'll just Control F5, build and run this, and you'll see that the loop successfully exits. We get the value of I following the loop that gets printed, and the program exits with code 0 as well. Close out of that. So I would like to note here that even though I can do this, so where I have the expression where I change the counter variable, I can have it in the loop, but it's kind of bad practice to leave these things out, okay? You want to include all of those statements between the parentheses of the for loop. Otherwise, it's considered bad practice. So I'll just add that back. I'll just do I is equal to 1 just to change that out a bit. And if I build and run this now, the loop starts at 1, so we'll print from 1 to 9, and then we'll get 10. Initialization of the loop control variable will typically start at 0. And the reason is, as I mentioned, is that we typically use for loops to loop through arrays to get the values that are within those arrays, whether we want to print them out or use them in some other way. Okay, as we'll see in an upcoming lesson. And arrays start at 0. They do not start at index 1, they start at index 0. But we'll talk about that later. What you will also often see is, I'll remove those brackets. I'll just make sure that I have some indentation here. And this is fine. So this is now part of this loop. I'll just build and run and you'll see what I mean. You can see that that loop does execute. So if it's just one line, then this is fine. But otherwise, this will not work. So if I do something like this, you can see we still only repeat this single statement within that loop. This one will follow the loop. Okay, and so this will be very difficult to read because of the indentation. So you always want to make sure that you have proper indentation. And again, if you don't have a code block, then it will only execute this single statement. Now there are ways around that. So you can do something like this, and then you can do a comma, the comma operator. Remember that the comma operator separates out expressions. So we can do another expression where we do shout. I'll just do a return. Something like that. I'll build and run this. And you'll see after every line, we get a thanks. the loop will end and exit, and then we get that final statement as well. So again, these are expressions, and you can separate out expressions using the comma operator. But I would not really recommend that you do it this way. This is also bad practice because this makes reading it difficult, and it's just not a standard. So if you want more lines like this, then instead I'm going to replace that with a semicolon, and what I'll do is I'll just cut and paste those to have these two lines within opening and closing curly brackets, so within a code block, and each statement within that will end with a semicolon. You can see we get the same result. Okay, I'd also like to note that this does not have to be increment or decrement. What you can do is something like this, for example. So we'll add 2 each time. I'll just set I back to 0, build and run this, and you see we start with 0, 2, 4, 6, 8, and so on. So it's going to add 2 each time. So this is simply the expression where we change the loop control variable, in this case I, and typically we do increment or decrement the counter variable. That's the same thing for while loops as well, but I just wanted to mention that that does not have to be the case. You can write whatever expression you need right in this space. Let's say we want to count down instead. So we'll start with 10. Okay, I'll set the variable I to 10. And I'll set the Boolean condition, or that Boolean expression, to I greater than 0. So as long as this is true, this will count down basically. That's what I want to do. So I'll do minus minus to a decrement I each time. As soon as this reaches 0, this loop will exit. So I can just build and run that. So you see, instead of starting at 0 or 1 in this case, we start at 10 and we count down. It's important to remember that this will print out in the loop. It will print out to 1, but then it will still go and decrement that counter variable. So that will be 0 following the loop. Okay, I'll undo a few times, or you can just retype it like this. And of course we can add if statements. So let's say I, and that modulus operator, which is the percentage sign in C++. So in other words, the remainder after division, if that is equal to 0, then you print this out. So in this case, the remainder of I divided by 2. So this is going to print out even numbers. So let's just build and run this and we'll see what happens. You see we get 2, 4, 6, 8, and so on. You can change this to 1, Control F5 to run, and now we'll get the odd numbers. So 1, 3, 5, and so on. But the point here is that you can use if statements within for loops, as well as while loops and some of the other statements as well. And again, because this is a single statement, this is fine, but typically you want to do it like this, so it's more readable and so that it's easy to go and add more stuff in here. Okay, I'll just do some cleanup. Now, as I mentioned previously, you can also use the comma operator to separate expressions out. And you've also seen previously that we can initialize or declare and initialize multiple variables using this comma operator as well. So J, for example. So now in this loop, we have 2 variables. We have int I, which is set to 1, and int j, which is set to 2. So I increment int I. Let's say increment j as well. Okay, so with each repetition, I want to print out I and j. So I multiplied with j is equal to, and then here I do the actual computation of that, and I end the line. So I'll just build and run this, and you'll see we get this 1 times 2, 2 times 3, and so on. So basically what I'm doing again, as you can see, I'm separating the expressions with the comma operator. Now this is also bad practice. For the most part, you don't want to do this. It can be kind of confusing, difficult to read, but as you can see, you can do this, and you might see it in someone else's code.